This semester, we've learned a lot of great techniques we can use to be successful educators. I was a bit concerned about teaching math before this semester, but the more I learn, the more comfortable I've become with it. I'm finding as I explore the curriculum in our textbook, they're really in tune with how students learn best. As a child, I struggled with a lot of areas in math. Number sense and numeracy was one of those areas. I felt like there wasn't a lot of opportunity to explore different ways of learning. I was so focused on memorizing the steps to take that I wasn't really thinking about the numbers and what they mean. So that's why I've particularly enjoyed learning about alternative algorithms for addition, subtraction, multiplication, and division. I've learned that there are actually studies that found what I was experiencing growing up, that students were so busy trying to remember the formula that they weren't using logic to solve the problems. I really like alternative algorithms for whole number operations because I find that it really focuses on how we already do math in our minds instead of trying to make up something new to write out on paper. So I'll go through some examples of alternative algorithms to show what I've learned on the topic from the article, Alternative Algorithms for Whole Number Operations. For example, let's say we have 362 plus 403. So we want to make sure they focus on place values. So we'll start with the left column, going 300 plus 400 equals 700. Now we'll do 60 plus 0 is 60, and then 2 plus 3 is 5. So that brings us to 765. So let's say we start with the example 47 minus 24. For adding up, the students are welcome to use friendly numbers to get to the final number. And we have to remember they're comparing numbers. So to start, we'll do 24 plus 10. We're comfortable with 10. We can use that. So now we're at 34. And we know we can do another 10 on there. So now we are at 44. And then we're missing 3. And that brings us to 47. So now we have to count how many jumps we took to get to 47. So 10 plus 10 plus 3 is 23. So 47 minus 24 is 23. So we'll use the example 72 minus 46. We'll start with 70 minus 40, keeping in mind place value, which brings us to 30. And then 2 minus 6 is minus 4, which brings us to 26. Partial products is quite similar to partial sums and differences in the sense that we focus on place value again. It's also great because there's no adding up. The following is what you could see for an example that a student could give, which would clearly demonstrate their work. example of the lattice model. So this model does ignore place value, which is a disadvantage, but it has the advantage of delaying addition and carrying until multiplications are complete. So this is more of a breakdown of the numbers as well, which students find easier. Now, once we are finished the setup, we do have to record each partial product. And once this is all finished, we add along the diagonals. So we will have 2 here, 4 plus 4 is 8, and then 8 here. My personal favorite way of multiplying is actually not taken from the article. It is set up as an array. So first you would be breaking down the numbers for the students to make this easier. If I were to model it for them, let's say 38 times 65, I would first start breaking down 38 to what I would be comfortable multiplying with. So for me, I chose to have 10 3 times and then the number 8. And for 65, I felt comfortable multiplying by 50 and then the rest 10 and the number 5. Now you have to set up the array as you would with base 10 blocks, except now you're just using the numbers themselves. Once the array is set up, it's very clear what needs to be multiplied. So you start with the top columns, 50 times 10, which I know is 500. It's nice this way too because I know the answer 50 times 10, so I can put it in the next 2 spaces as well. And then we have 50 times 8, which gives us 400. Now we go to the next row. And again, it's easy for the students because they know 10 times 10, they're working with friendly numbers, equals 100. Now we have the answer in the first row, so we can just input the answers in the next 2 sections. Followed by 10 times 8, which is 80. And then we go to the next row and do the same. And once we have inputted all of our numbers, we need to add them all up. So students can use different strategies to do this. They can take row by row, or what I chose to do, I saw that the first 3 vertical rows were the same. So I did 500 plus 100 plus 50. Which I know equals 650. Now I know that the next 2 rows look the same, so I will do 650 plus 650 plus 650. Afterwards, I will just have to calculate the last row. depending on what numbers these students wanted to work with, these steps could look different. They might have different breakdowns. They might add differently at the end. They might multiply differently. But it is a clear demonstration of how they are thinking and what processes they took to get to the final answer. This last algorithm was particularly exciting to me because I always struggled with division and not knowing the proper way to go about it. So with repeated subtraction algorithm, it's actually wonderful because it allows students to approximate how many times a divisor can be subtracted from the dividend, and it also builds on number sense and problem solving. So again, they're taking numbers that they are comfortable with to do so. So I know that 5 times 10 is 50. And then if we subtract 50 from 150, it's 100. Now students can also use strategies here. For instance, I know that 5 times 10 is 50. And if we double that, using a doubling strategy, that brings us to 100. So 5 times 20 is 100. And if we do 100 minus 100, it's 0. There's no difference in the numbers. And then once we are finished with this, we have to add 20 plus 10, which brings us to 30. I think all of these algorithms are great ways for students to show how they're getting to their answers without being completely stuck on getting the formula right. It gives them a lot of options to go through problems. They're actually thinking about numbers and place value and solving the problems like a puzzle. Not every student is going to approach a puzzle the same way, and I think that's a great way to go about teaching number operations as well. I'm really looking forward to incorporating these algorithms into my own classroom someday.